Good morning. Today we are studying about Hooke's law. To study this, first we have to study the definition of the Hooke's law. Now to define the Hooke's law, first we are telling that stress is directly proportional to strain. This is the definition of the Hooke's law. Stress is directly proportional to strain. Now this can be also written as stress. We have to use this directly proportional sign. For that we are taking some constant term, that is capital E into strain. Now this can be also written in the form of E is equal to stress by strain. Stress by strain. Now this E we are calling it as modulus of elasticity or the coefficient of the elasticity. Now first we have to know that stress means, definition of the stress is the force per unit area of a body. We are calling it as stress. Second one, strain. Strain means change in the length or change in the dimension to its original dimension. Then we are calling it as what? Strain. Now in this case, according to the Hooke's law, we have taken E is equal to stress by strain. Now this E means what? It is the modulus of elasticity. Modulus of elasticity or the coefficient of elasticity or coefficient of elasticity. It means what? Modulus of elasticity or coefficient of the elasticity. Now next we have to define the modulus of elasticity. Modulus of elasticity. Or for this we are also calling it as moduli of elastic or moduli of elastic. This can be denoted as capital E. Capital E is equal to, we can got here formula as stress by the strain. Stress by strain. This is the definition for your modulus of elasticity or moduli of the elastic. Now next here we are studying the definition of this. E is equal to what we are getting here? Stress by the strain. This is the definition of the modulus of elasticity. This modulus of the elasticity is depend upon your Hooke's law. First, if you know the Hooke's law definition, we can tell easily we can define the modulus of elasticity. According to the Hooke's law, we can tell the definition as stress is directly proportional to the strain. And in the modulus of elasticity, we are taken E is equal to stress by strain. Now next, we have to study the three types of elastic modulus or modulus of elastic. Three types of elastic modulus. Now first one we are studying about the Young's modulus. First one is Young's modulus. Second one, bulk modulus. Bulk modulus. Third one is shear modulus. These are the three types of elastic modulus we have to study. First one is your Young's modulus, second one is bulk modulus, third one is your shear modulus. Now according to this, or to define all these three, first we have to know the types of the stresses, and strain. Types of stress and strain. Now here also there are three types of stresses and three types of the strain. First one we are studying in this stress. First one is your longitudinal stress. Longitudinal stress. Second one, value stress. Third one is your tangential stress. These are the three types of stresses. Now in the strain again we are studying the three types of stress. First one is your longitudinal strain. Longitudinal strain. Second, value strain. And third one is your tangential strain. Now, by using this, we can define all these three types of your elastic modular. In the first case, we have taken here longitudinal stress, and in the strain, we are considering the longitudinal strain. Now, according to the Young's modulus, now we have to define your Young's modulus. Now, Young's modulus can be defined as here. First one, what is the longitudinal stress, and other one is your longitudinal strain. We are considering the formula longitudinal stress by the longitudinal strain. Now we have to define the Young's modulus. Young's modulus is the ratio of the longitudinal stress by the longitudinal strain. Then we can call it as Young's modulus. This can be also written in the form of. Now we know the formula for the stress. The formula for the stress is F by A, that is force per unit area of a body. Next one, we are considering the longitudinal strain. According to the longitudinal strain, we are considering change in the length to its original length. Now we are considering delta L by L. Now by using this, we are getting the equation as F by A into L by delta L. This is the formula for your Young's modulus. Here Young's modulus will depend upon your longitudinal stress by the longitudinal strain, and this can be written in the formula F by A divided by delta L by L, or this can be written as F into L divided by A into delta L. This is the Young's modulus, and this Young's modulus can be always denoted by capital Y. It can be always denoted by capital Y. Now next, second one, we are studying about the bulk modulus. Second one is your bulk modulus. Again here we are considering the formula as it is the ratio of the value stress by the value strain. Value stress by value strain. Now again we know the formula for the value stress. Here in this case we are considering force per unit value of a body, that is your value stress, whole divided by value into strain, delta V by V, F by A. Next we are considering the formula as F into V by A into delta V. This is the formula for your bulk modulus. Bulk modulus can be defined as it is the ratio of the value stress by the value strain. This value stress formula we are written as force per unit area, value strain delta V by V. Delta V means change in the value by the original value. Next we are getting F into V by A into delta V. This is the bulk modulus. Now last one is your shear, and it can be always denoted by capital B. Capital B means what we are calling? We are calling it as bulk modulus. And last one is your shear modulus. Shear modulus. In this shear modulus, it can be denoted as capital R. Capital R means what we are calling? We are calling it as shear modulus. Now according to the definition of this, we are considering it is the ratio of the tangential stress by the tangential strain. Tangential stress by the tangential strain. We are calling it as what? Shear modulus. Now again we have to write the formula tangential stress. We are writing F by A, or we can take any one. In the case of the area, we can take theta whole divided by, we are considering change in its value. Just we are writing delta theta by theta. Therefore, we can write the equation as F into theta divided by A into delta theta. This is the shear modulus. In the elastic moduli, we are studying about the three types. One is your Young's modulus, bulk modulus, and shear modulus. To know this, all fully depend upon your shear and the types of the stress and the strain. Now next, we have to study about the elastic energy in the stretched wire. We have to know the definition of the elastic energy in a stretched wire. To define that, just we are considering the energy stored in the wire The energy stored in the wire is called as elastic energy in the stretched wire. Next, we have to write the expression for the potential energy in a stretched wire. We have to write the expression for the potential energy in a stretched wire. In a stretched wire, the expression for the potential energy in a stretched wire, we are considering potential energy PE is equal to 1 by 2 into stress into strain, and again we are considering the volume of a wire. Now next, this can be also written in the form of Y is equal to, we are writing thrust by strain. Y means it is the Young's modulus. Young's modulus, what we are defining? Thrust by strain, or this can be also written as thrust is equal to Y into strain. By using this definition, we can write thrust is equal to Y into strain. Therefore, the potential energy per unit value, of the wire can be written as 1 by 2 into Y into strain square. This is about your potential energy. Here we are considering the potential energy per unit value of the wire can be written as the equation 1 by 2 Y into strain square. Y means it is the Young's modulus. See here, potential energy in a stretched wire, we are getting the equation as 1 by 2 stress into strain into volume of the wire. Here what we are getting, just 1 by 2 Y into strain square. Now again one more we are studying here Poisson ratio. This can be denoted as sigma. Sigma is equal to, we are telling, lateral strain by the longitudinal strain. Here we are not considering the stress, only both sides we are considering about the strain. So here Poisson ratio means what? It is the ratio of the lateral strain by the longitudinal strain. Then we are calling it as what? Poisson ratio. Or this can be also written in the form of dr by r. And in the case of the longitudinal strain, we are considering dl by l. Or this can be also written in the form of minus dr by r into L divided by dl. The negative sign tells that if the R goes on increases, L is also goes on increases. This is just about your Poisson ratio. Poisson ratio always denoted by the sigma. Sigma is equal to, we can tell that it is the ratio of the lateral strain by the longitudinal strain.